Okay, Assalamualaikum warahmatullahi wabarakatuh. To Dr. Matsah. For today, I would like to talk about the assignment 4, which is to convert the audio to image for subject multimedia data processing. So my name is Muhammad Anas bin Adnan. My metric number is P19EC0043. So what I'm going to talk about today is the first introductions, given solutions, proposed solutions, flowchart, script, procedure, output, and conclusion. So for introductions, we need to convert the audio data into a spatial data presenting using the fundamental image processing and an understanding of the audio and speech processing in order to complete this project. I need to come up with a better or improved approach that will make use of attributes to display audio data in a more clear and understandable spatial data presentation. To create an image of each audio, I must understand the properties and the pattern of the audio. So this is the given solutions. The suggestion approach use a simple point-to-point direct mapping with no attribute. The given output is in a grayscale. So my proposed solution, I decided to separate the audio frame by frame. Each frame will contain the size of 256. So I calculate the energy after separating the audio into the frame and then use the energy as the variable to convert into a spatial data presentations. The use of energy as an attribute could make it simple for the viewer to understand the audio. The viewer can tell which section of the color has a higher energy value and which part has a lower value by looking at the intensity of the color. So this is my flowchart, which is the first step I've tried to do is to load and read the audio file and then to calculate and separate the audio file into 5-6 matrix. So and then I will calculate the energy on each frame. After that, I will mean and max are fine for normalizations of the value, and then determine the color and intensity using energy value, and then normalize the energy value of all frame into 0 to 1, and then map the value into an array, and then reshape the value into two-dimensional metric. So after that, I will divide the metric for a better contrast, and then and for the last part is to display spatial data presentations. So this is my script that I have wrote. So the first script is in the sample call, and then the second script is within the functions that I've used. So this is the continuous script of the functions. Okay, for the procedure. So procedure. First of all, I will for this audio file is being read with audio read, and then sample map is being called to map the audio into the image. The sample map is the function that I've wrote. So f is the square root of the number of a frame produced from the audio. Square root is used so that it can be easily to declare the dimension later. The loop will calculate the energy value of each frame and store in an array. Min A and max A are minimum and maximum of the energy. So half is for determining the color. So for this, it's time to map the audio after determining the energy of each frame. I use a simple RGB color with red representing the highest energy value and the blue representing the lowest. To make the spatial data easier to understand, various color saturations and color intensity can be used. Color in the MATLAB is represented by three value R, G, and B. Hence, a metric with a color will require three metrics. So the color changes based on the energy, and the color changes around the red and the green value if the energy is greater than half of the entire range of energy. If the color is less than half, the color shift to green and blue. In addition, the value between 0 and 1 is normalized in these sections. The approach I use for plotting the image has a pixels value range of 0 to 1. Uh, this is the normalizations formula. So normalize x equal to x minus min x divided by min x minus min x. So the array produce is one dimensional array with a value of one column. Reshape is used to produce a two-dimensional metric. Pixels value of R is divided by 0.5 to show a better contrast when displaying. Uh, this is my output. To test the output, I use three different audio files. The energy of the audio is represented by the spatial data representations frame by frame. Higher energy is represented by a red in the output, whereas lower energy is represented by dark blue. Each audio has their own unique pattern when turning into a spatial data representation. Conclusions. So finally, the proposed method performed well and effectively represented audio using attributes such as energy in a spatial data representation. Based on my observations, I believe that converting the energy of each frame's audio into the visual will help a viewer understand the audio features. I learned more about fundamental image and speech processing, as well as the process of converting audio to visual. As a result of this assignment, there are a variety of alternative ways to express the data, such as using other attributes. I think that's all for me. Thank you.